Hello and welcome to CED. Before starting the video, if you like the content of the video, do like the video and subscribe the channel. So today's question is to design the Turing machine for finding the log of n value, where n is a perfect power of 2 and it is a binary number. Now what is the perfect power of 2? When we are finding the binary number system, we used to write the base 2 with the powers as 0, 1, 0, 1 and 2 and so on. So this is called as the perfect power of 2. So what will be the answer? The answer will be 1, 2, 4, 8. Why we are not selected 3? Because 3 is not perfect power of 2. How it is not a perfect power of 2? Because it's going to start with 1 and after that is also having 1. So this is the binary equivalent of number 3. Why 5 is not the perfect power of 2? Because it's going to start with 1 followed by 0 and followed by again 1. So this is also not the perfect power of 2. Now if we are going to have 7, we'll start with 1 and it's going to contain 2 more occurrences of 1. Perfect power of 2 are those numbers which are going to start with single occurrence of 1 and after that is going to have the combinations of 0 but it's not going to have any occurrence of 1 after the first occurrence of this one. So these are called the perfect power of 2. Now, for finding the log of n, we will consider the perfect power of 2 in decimal number like 1, 2, 4, 8. Now, we will write them in the base 2 format. So, it is base 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. Now, if you are going to find out the value of this number, log of 2 with the index 0, so the answer will be 2 we are going to shift here. So, this will be 0 into log of 2 to the base 2. So 0 will be multiplied with the value of log 2 to the base 2. Always the value of log 2 to the base 2 will be 1. So your answer will be 0 into 1. So you will get the answer as 0. Now for the second one, for finding the value of 2, that is 2 raised to 1. So what will be the answer? It will be log of 2 to the power 1 and base 2. So this will be shifted here. So we'll get 1 into log of 2 to the base 2. And we know the value of log 2 to the base 2 is 1. So 1 into 1 will be answer 1. So here we got the answer as 1. For log 2 to the base 2, log 2 to the power 2 will be, it will be log of 2 to the power 2. So 2 will be shifted here as it is visible here into log of 2 to the power 2. So 2 into 1 will be answer will be 2. Now this number we will write in the binary notation. So if we are going to write, because we have to consider n in a binary format. So 2 raised to 0 is 1. So in binary it will be 1. 2 raised to 1 is 2. So in binary the number 2 is 1 0. 4 in binary notation it is 100. 8 in binary notation is 100. Now the answer for the log 1 we already got that this is 0. Log value of log of 2 to the power 1 will be what? That is in binary format. 2 raised to 1 we are writing in binary format, so answer will be 1. Log of 2 to the power 2 in binary format 4 we are writing as 100. Your answer will be 2. Log of 2 raised to 3 will be your 8. It is containing 3 zeros, so the answer will be 3. Now, if you are going to compare the values or the answer of log of 2 to the log of 2 in binary number system, we can find out the number of zeros which are present here will be your answer. In case of 1 0, which is number 2, your answer is 1. In case of number 4, which contain 2 0, your answer is 2. In case of binary number 8, which contains 3 zeros, your answer is 3. So the answer is already present in your question. So if you are going to write the perfect power of 2, for example, if you are writing 16, so what will be the perfect power of 2 is simply the number of 0. That means what is extra here? Number 1 is extra here. So what if anyhow we are going to make this number 1 as blank symbol? So what we'll get? We will get only the sequences of 0. So that is your algorithm. We will mark this number which is present into, or we will convert that number into blank symbol. So this 1 will be converted into the blank symbol and number of zeros will be 1. But one more precaution we have to take, that we have to be careful while moving. So after converting the first occurrence of 1 here into blank symbol, we want the remaining thing should be the sequences of 0. We should not get extra 1. If you are going to get the extra 1 in between, that will not be your perfect power of 2. So what we're going to do after converting the first bit, which is your 1, into blank symbol, we will move right and check for the any occurrences of 1. If by mistake we got any occurrence of 1, so that is your error and will stop your algorithm there. Otherwise, whenever we are having this number and we are going to convert the first occurrence into blank symbol, we will just bypass all the sequences of the 0 and will move toward the right hand side till we get the end of the string. After getting the end of the string, we will stop our algorithm. So what we are going to do, we will consider our tape for writing the, for designing the Turing machine. So all the blank symbols will be present here. Now we will write our string here. For example, we are having string 1 triple 0. So what is our algorithm is that whenever we will get 1 in the initial position under Q0 state, we will convert that into the blank symbol and we will change the state as Q1 and we will move towards the right hand side. So this is what we will get after the conversion. Your first number will be converted into blank symbol and we are shifted towards the right hand side. Now after conversion of the number 1 into blank symbol, what is your second step is to bypass all the zeros. So what we will do, so q1 under 0, q1 with the input symbol 0, what we are going to do, we will move towards the right hand side with the resultant state as q1 only. So this is your, we can say, the next step. So q1 with the 0 we have shifted towards right hand side. Now q1 again with 0 is again we are going to shift right hand side because we are going to bypass all the zeros. Again q1 with the 0 is that we are going to move toward the right hand side. Now this is your q1 with the blank symbol, that means we have reached the end of the string. So once we got the end of string without having any second occurrence of 1, so this is your accepted string. So we will stop here and that is indicated by a new state which is called as a Q state. So what will be the distinct solution? So Q1 with B will be Q2 with the halting position or the no movement. So here after considering the algorithm, we have written the state transition table Q0 with 0 with all the zeros. For example, if your string has started with 0. So at that time also we will bypass because this 0 is not having any value. So Q0 with 0 because this is number 4. Number 4 can be written as 1 0 1 0 0 or simply 1 0. So this 0 before 1 is not having any significance. So what we are going to do, we are going to just bypass the first bit till we are getting the first occurrence of 1. So Q0 with 0 we will shift towards the right hand side. Now Q0 with the first occurrence of 1 is that we are going to convert it into a blank with the resultant state as Q1. Now if we are having Q0 initially with all the blank symbol, we are not having any string, so what we can report this as an error that there is no input symbol for which we have to find the log of n. Now we are having Q1 with the zeros, all the 0 we are going to ignore, but if we are having, suppose we are having this kind of string, we are Q0 on 1 will be this 1 will be converted to blank and will be shifted towards the right hand side. Q1 with 0 will be moved towards the right hand side. Now if we are getting 1 in Q1 state, so that is, this is your number is not a perfect power of 2, so we have to report the error. And now at the end, if we reach the end of the string, so we will stop the um, transition there only. Now what we are going to do, we are going to draw the state transition diagram. So how we will draw, we will take first the initial state. The initial state is Q0. Q0 on 0 is only shift towards the right hand side and will be in the same state. Now Q0 on 1, that is going, it is going to Q1 and it is making the blank symbol. 1 is converted into the blank symbol and is going to Q1. Now Q1 on 0 is going to same resultant state and it is moving towards the right hand side. Q1 with 1 is error, so we will not indicate that. Now Q0 with the blank symbol is that we are going to have the no position. We are not going to have any movement and will go to the final state. So this is how we have designed the Turing machine for finding the log of power of perfect power of 2 when n is your binary number system. Hope you people have understood the concept. Do like the video and share the video. Thanks for watching.